It's connecting the parabola with a quadratic function. So it's just making that connection. When we say quadratic, we know that it has a magnitude of what? Quadratic. 2. Right? Quartic is 4. So a quadratic equation is simply written in standard form as ax squared plus bx plus c. And we normally see that equal to 0, so I'm going to go ahead and add that in. So this is standard form. It goes in order of magnitude, x squared, x, and then no variable. Okay, keeping in mind the a, b, and c are simply coefficients. Okay, so they're just numbers. So another one that you might see in standard form, I'll just give you the example of 2x squared plus 3x minus 4 equals 0. Okay, so that was one that would be represented in standard form for us. So a quadratic equation has an equal sign. A quadratic equation has an equal sign. We have to keep in mind that x cannot equal 0 in these cases. So standard form of a quadratic function you may see written as y equals ax squared plus bx plus c. You might see it as f of x. Remember that those are the same thing. Okay. So when we say quadratic function, of course it's going to be written in function notation. So f of x equals ax squared plus bx. You don't necessarily have to write this down, but we have to keep that in mind. Okay, so anytime we say a function, we're going to see it in function notation. Just remember that f of x is the same as y. It just means it's the output. It's the output. The function where x is our input is what that means. Any questions thus far? Yay. Example 1. So converting to standard form, so we're going to start with this equation, y minus 6 equals 2x minus x squared. So in order to convert this into standard form, I want to get all of my let's say, how do I say this better? I want to get my y by itself. There you go. I'll get my y by itself. So I'm going to get everything else away from it. So here I'm isolating my y. What do I need to do? I'm adding 6. Simple enough, right? So I add 6 to both sides. I'm left with y equals, now I need to start writing this in standard form. Okay, I wrote it over here next to it so that I knew that this is my new equation and I need to set it up in standard form. So I have a negative x squared plus 2x plus 6. Anybody confused there? Okay, just remember that if it is minus x squared, it goes up there with it. That negative travels with it. And since this is a positive 2x, it becomes plus 2x. Okay, positive signs and plus signs are the same exact symbol. Okay, so that's in standard form. That was the end of that problem. That was A. Part B gives us this equation, f of x, so this one's in function notation, equals 2 open parentheses x minus 4 squared plus 9. So I'm going to rewrite this so that you realize what we're doing here. So we still have f of x. It still stays in function notation. This 2 is on the outside. Now I have to perform this x minus 4 squared before I can do anything. Because in order to get rid of these parentheses, I have to do the exponent. So this is x minus 4 times x minus 4. These two are being multiplied by each other. And we add 9 at the end. So I just added these brackets so that you could see I have to do this first. So it's simple FOIL. So I do first times the first is the first, outside, inside, and then last. So first times first is x squared. Keep that 2 on the outside. I'm just going to drop down my f of x real quick. Okay, so first times the first is the first, x squared. The outsides are negative 4x. The insides, again, negative 4x. And then the last, positive 16. So if you remember the shortcut, you can go ahead and do it. You don't have to write all this down. And at the bottom, I just drag down my plus 9. Combine like terms in the middle. I have a negative 4 and a negative 4. Gives me a negative 8x. And I just copy down everything else. Okay, give you a second to catch up. Okay, are there any questions up to this point? Okay, I see a lot of mistakes being made right here. I see y'all guys distribute this 2 to each piece, and I end up with an x squared plus 16. Make sure that you know that this parentheses means this is all inclusive. This whole thing is being multiplied by itself. Okay, we don't just simply distribute out exponents. All right, from here now I can start distribution of this 2 right here, so I will distribute it out to everything inside of my parenthesis. So I have 2x squared minus 16x plus 32 plus 9. And then again, combine like terms that I have. I have 32 and I have a 9. Now I know this seems like a lot of work, but once you do it a couple times, you'll find all kinds of shortcuts that'll eliminate several of these steps. Okay. So I've gotten down to standard form. I've converted it completely, and I'm at the end, so I will circle my answer. Now, if it asks you, identify A, B, and C, which I'm going to ask you several times, what is A in this function? What is A? It's not 2x squared, it's just the 2. Yes? 41. Did I say 91? I wrote it down, but I'm pretty sure I said 41. My bad. It will say all. Let's go back to the footage. Instant replay. Okay, so A is 2. B is what? Negative 16. And C is 41. Not 91. Okay? Alright, so in order to graph a parabolic function, we can do that by graphing several points. But we need to know a few things before we get there. So there's a thing called the standard, or not necessarily standard, the parent function that we'll learn about how to graph these out. So this is what it looks like. Parent function will be a function of x where it is equal to x minus h squared plus k. Now some of you might have seen this before. I'm not sure your complete math experience. But this comes in handy because you'll see a vertex. Remember what a parabola looks like, okay? All quadratics will be some form of parabola. It'll be opening up or opening down. But there's always a minimum or a maximum. I'm going to call it the vertex. Okay? So there's always a minimum or a maximum, and it's located wherever it stops going up or it stops going down. So this point is called, I'm going to call it the vertex. So the vertex will be located at h comma k. H comma k. So this is where those come from. And a lot of people get confused, so I'm going to use a literal example here in a second. But it's opposite of the first, keep the second. Opposite of the first, keep the second. So the reason I say opposite is because this minus here would throw us off. And I'll give you an example here in a second. And then it'll say, what is the axis of symmetry? So the axis is a equation for a line. Okay, so axis of, I'm going to spell this wrong, symmetry. The axis of symmetry is going to be an equation. It'll be x equals whatever h is. So it literally just drops down into whatever that is. It's what splits it down the middle. The axis of symmetry, all parabolas can be folded in half. And they're exactly the same on the right side as they are on the left side. Okay? They just go up continuously forever and ever. So those are the main things that you'll see from this. Up here we'll see an A. I left a room for it. But that just tells you how fat or skinny it is. And that will basically talk about compressed or stretched. So stretched is when it gets skinny, and compressed is when it gets fat. So when we see the absolute value of A as a less than 1, that's when it's going to get fat. Okay? In other words, it will be fat. But in reality, it's called compressed. Okay? So for compressed, the absolute value of A will be less than 1. For stretched, or skinny, right? The absolute value of A will be larger, larger than 1, which would be greater than 1. Okay? Now if there's nothing up here, that's just mean it is equal to 1, and that is part of the parent function. Make sure you guys get caught up before I start my example. And I need a piece of lead. The parent function comes in really handy when we start graphing these. Okay, is anybody still working on catching up there? Okay. Moving on then. Here's my example. for this. It is f of x equals 2 open parentheses. I should just use their example. I'll use their example. X minus 4 close parentheses squared plus 9. So this is called this is from the parent function. I can gather all of the information that I need. Vertex form. It's called vertex form. Okay. So the reason it's called vertex form is because I can identify the vertex. The vertex is at h comma k, so I'm going to identify what my vertex is. H is 4 and k is 9. Now the reason I say take opposite of the first is because it looks like it's negative 9, doesn't it? Or sorry, negative 4. So since it looks like negative 4, I'm going to take opposite of negative 4, which is just positive 4, and I'm going to keep the second, which is 9. So opposite of the first, keep the second. So my vertex is there. My axis of symmetry is at x equals 4. And then that last bit of information will ask us, is it compressed or is it stretched? Since 2 is larger than 1, I'm going to say it is stretched. What can't you see? I said it out loud. Okay, any questions there? Okay, vertex form is very, 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 very helpful. So keep that on a note card somewhere. Okay. When we're talking about the zeros of an equation, you guys, when you use my stamp, make sure it gets closed so it doesn't dry out. Okay, when we talk about the zeros of a parabolic function, we're used to seeing them like x minus 3 and multiplied by x plus 5 equals 0. And then we solve each of these equations for when they equal 0. Right? We're used to seeing this. But when I talk about the zeros on a graph, I'm talking specifically about where it crosses the x-axis. Okay? It's where my y equals 0. So here's one of my zeros. Circle it real big. And here's the other one of my zeros. It's where it crosses the x-axis. Okay? So my zeros are where they cross the x-axis. And there's a function in your calculator when you click on your graph, you click calc, it says 0, and that's what you're finding, is where it crosses the x-axis. It's the x-intercept. So in essence, finding zeros is finding the x-intercepts. And when I learned what an x-intercept was, it was told to me as when y equals 0. When y equals 0 is what an x-intercept is. Okay? Alrighty. So that little definition's down. So everybody needs a calculator. If you don't already have one, go grab one. Everybody's got one. Sweet. Okay, so in your calculator, we're going to type in this equation. So take your calculator, click on y equals. If you're in parametric mode, we need to get out of parametric mode. Okay? So go y equals. I'm in parametric mode. So I'm going to go mode, go down, click on function, and then go back to my y equals. It should be cleared out. If it's not cleared out, just clear out anything that's there, and we'll start fresh and new. So our equation is negative x squared plus 3x minus 2. Okay, this graph should pop up. Let's all set our window so we have the same exact looking graph. So go to your window, type in negative 10 for your minimums, positive 10 for your maximums, and scales of 1. So that we all look like the same graph. First thing I want to be able to identify, if I want to write the equations of this line in vertex form, I would need to know the vertex. So I can find the vertex by finding its minimum or maximum. Am I going to be looking for a minimum or a maximum here? Is this a high point or a low point? High point. So I'm looking for a maximum. And I can do that by going second, calc, go over here, maximum. And then my little daughter dill is over here on my left side. It's asking for the left bound. So left side of it is over here. And then I need to move it to the right side of it. So I just tab on over. I'm on the right side. My little daughter dill is right there. Press enter, and then guess. So I just go to where I think it's at, and I press enter again. It should spit out an answer for me relatively quickly. So I'd round this to 1.5, comma 0.25. Did anybody not get that answer? All right, so that point is our vertex. So I could write that down, 1.5, comma 0.25, and that would be my vertex. These calculators have a tendency to give you a long slew of 9s, so just go ahead and round it to the last set of 9s. So here I'd round it to the 10th place because that last 9 is right there. Okay. Some of your calculators might have actually spit out 1.5. I don't know why they're rounding so weird. But anyways, 1.5, comma 0.25 would be our vertex. That's how you can find that. Yeah. Now, the harder part is finding our intercepts. Where does it cross the x-axis? Because it's clearly just barely above it, right? It's barely above it.
Right, what if it goes like way above it, but it crosses the x-axis?
Right. Here it's crossing in 2 places. You just can't see it. So let me zoom in real quick, and maybe you will be able to see it. See it right there now? Boom. 2 places it's crossing. So when you zoom in, you can kind of see it a lot better. Let me see if I can get this thing to adjust. Apparently not. Okay. Okay, that's a little better. So now I can calculate my zeros. In order to do that, I'll press, everybody go ahead and zoom in on that spot. You should already be in on the vertex, so go ahead and zoom in, and it'll already be on your vertex, so you can zoom in on your vertex. Okay, once you get to that point, we're going to go calc again. We're going to look for a 0. That'll be the second one down. Okay, it says left bound. So when it's talking left bound, it's not talking left of the vertex. It's talking left of the intersection with the x-axis. So I'm going to look for this one first, the one on the left. So I'm just below my x-axis. Right bound is just on top of the x-axis. And I press enter there again. Guess is where I think it crosses the x-axis. And I press enter again. And it crosses the x-axis at the first point at 1, 0. Okay, so I would write that down. That's one of my zeros, 1, 0. And then when I want to find my other one, I do that same calc function. I go down to 0, and then I just do it on the right side. So left bound this time is right up here near the vertex. My right bound will be just below the x-axis this time. And I press enter again, and then I guess right where I think it might be. And that one's at 2, 0. Okay, so I found my 2 zeros. So I find that my zeros are at x equals positive 2 and where? X equals 1, right? So my zeros are at x equals 2 and 1. If I wanted to solve this back into a quadratic form, I remember that we solved these before. I could move this 2 by subtracting 2 to both sides, and I get x minus 2 equals 0, right? And then over here, if I did the same concept, I'd subtract 1, I'd get x minus 1 equals 0. Now that's just a little bit of extra information if you ever have to reverse engineer one of these. Okay, so going down from this point, we can look at a table of values that will make up this graph. So it gives us everything. So we could press second, instead of pressing graph, press second table. And it gives you just a table of values. If we need to change our increments here, because look, 1 and 2 are both at 0, we can see that very easily. But if we needed to know what, say, 1.1 was, I can change my increment by going second window, because it's like a window. Our table starts at 0. That's fine. Maybe I want it to start at -10. I don't know what you want it to start at. You can start it wherever you want. But right here where it has a little arrow that says up table, that's asking what you would like it to go up by. So if I change it to 0.1, it's going to increase my table by only 0.1 each time instead of a whole number 1. So after I do that, I just press enter on it, go back to my table, and notice that you've changed your increment by 0.1. Okay? It's just extra that you might need to do if you're creating a table of values. Any questions? Okay. Okay, so when we're graphing this, we only need to know first one, vertex, right? So our vertex was where? On that equation, where was it at? Yes, it's at 1.5, 0.25. So I would graph that very first thing. Okay, I need to graph my vertex. Now I know that's harder on these graphs that only go up by one whole increment. So you might change your increment to 0.25 or 0.5, whatever you need to do. Okay, so 1.5 comma 0.25 is approximately right there. Okay, so remembering that our equation was a negative, that means it's opening downwards. And if I look at my table of values, I'm looking for anything to the left, I repeat, to the left of my vertex, and anything to the right of my vertex. So since my vertex was at 1.5, something to the left of it would be 1. And we know that our zeros are at 1, 0. So since we already calculated our zeros, I'm going to go ahead and put them down. And the other one was just to the right of it. And then I just connect it, and we know the shape of a parabola is like this. So you only need 3 points to make a parabola.